what is 5G, including sub 6 gigahertz 5G and millimeter wave 5G? How does it work? And maybe the most important question is, how will it change the world in the coming years?
When we set ourselves to develop 5G, and we look at this, every generation of technology had a problem to be solved, right? So you mentioned 2G challenge. The challenge of CDMA was, can we give every person on Earth a cell phone? That was, can you get to a technology that you can basically allow everyone to have a mobile phone? 3G was about the ability to connect that to the internet. I think 4G was broadband, and with 4G, it was about have the ability for you to have a computer in the palm of your hand. We just talked about that. 5G, the challenge was a little bit different. It's how do we build a technology for a society that is going to be 100% connected to the cloud? How do we provide a technology that is going to be the last mile connectivity for everything? So 5G is basically been designed eliminate all issues with data congestion. Whether you are in stadium, we talk about soccer. You are in a stadium, and everyone should be ability to have access to broadband. So deal with congestion. Deal with the fact that not only people but billions of things need to be connected. Create a technology that, for the first time in wireless, you could deliver mission critical services. Wireless used to up to 4G is best effort. In 5G, it can guarantee that you're connected with the cloud. And then the last point of that is provide this fabric that will allow us as a society to look at things that are not connected and say that's the exception. That's why we made a comparison in the early days of 5G that's going to be like electricity. Right now, you don't have a discussion about what is the use cases for electricity. You don't talk about that anymore. You just assume it's there. And that's how we're thinking about everything connected to the cloud. That's what 5G is, and that's the role of 5G.
So first of all, everything connected to the cloud is interesting because the space of everything is constantly increasing.
That is correct.
I don't think the refrigerator over there, it looks kind of smart, but I don't think it's connected yet to the cloud. So this includes Internet of Things. What is the full space of everything?
The full space of everything it's maybe going back to where you start defining Qualcomm. Qualcomm is about communications and advanced computers for low power devices. And can we make everything smart? It can range from the robot you have right now on the floor to your refrigerator to a camera to machines in manufacturing to retail, etc. I can give you some examples. When we think of something as simple as going to the grocery shop, we see technology now with something the stuff we've been working with companies like Walmart, electronic shelf labels, the ability for you to have smart cameras that can look at shelves and the camera is smart enough to say some product needs to be replenished, ability to see what's there. So it's about really providing processor connectivity, artificial intelligence to everything. And I think that's one of the largest addressable markets we have for technology because you can't really define everything.
Right, exactly. It's a nice market because it keeps growing potentially exponentially in speed. What about coverage? So how are we doing on the everything part? So, there is, like I mentioned, sub 6 gigahertz 5G and there's millimeter wave 5G. So not all 5G is made the same. So there's a speed, there's a bandwidth thing, and then there's coverage. How many people get to enjoy today, and how does the progress in the next 5, 10, 20, 30, 50 years you think looks like in terms of coverage?
Great topic of conversation. So let's talk about this. When I meet with regulators across the globe, I tell them resistance is futile.
Yeah.
Allocate every spectrum to wireless. Every spectrum needs to be allocated to wireless. The reality is when we start moving from CDMA to OFDMA, we knew that this industry has done a lot to get more bits per hertz. But the reality is the massive amount of improvements that is required in capacity and in speed, you need more spectrum. There's not so much we can rely on more bits per hertz. You just need more spectrum. And if you look, for example, what carriers, since the 2G era, they participate in different license and auctions, and every spectrum they accumulated from 2G or 3G or 4G, all of that, you may be able to get one or two channels max of sub-6, which is a channel is about 100 megahertz or 200 megahertz, and that's it. So we need more spectrum. So 5G has been designed to work across every spectrum, from the low frequency bands, that's what we call the sub-6, but you needed more. You needed to go to the millimeter wave. So that's why 5G is a technology that you can deploy from 450 megahertz as an example, or 600 or 700, all the way to in the 42 gigahertz. And that's where millimeter wave comes into the picture. Now, let's now connect this to your question about coverage of 5G. The easiest thing to do is to deploy 5G in the new spectrum you can get, which is in the sub-6. You see bands being auctioned across the globe in the 3.5 gigahertz. There's nothing special about the band. It's just the only one that was available because everything else has been used for 4G. And you can deploy on that, go into existing cell towers and just put a new equipment without having to build new towers. But when we go to technologies such as millimeter wave, then you have to build more dense networks. You need to build more stations, because a deployment in that case look like a Wi-Fi deployment. It's almost like Wi-Fi access points. When you need to build more stations, you need permits. You need to build fiber, so it takes more time to densify. So what you see happening is coverage is being built fast with sub-6 across the globe. Now, the United States also have the sub-6. So that gets you the coverage very fast. But millimeter wave, it's moving. And if I will say, for example, Verizon, the United States has had a leadership in building millimeter wave. It takes time. I'll say cities like Chicago, Manhattan starting to get coverage. It will be a process over a number of years as you build those different access point type networks, but it's inevitable. There's not enough spectrum. So every 5G operator, it's just a matter of time, will have millimeter wave as well.
Resistance is futile. Okay, so for millimeter wave, we need density of access points. And what's the biggest resistance for Qualcomm, for human civilization? Is it politicians, regulators, federal regulators? Is it individual humans? Is it not enough money from the consumer perspective? Like, who is the biggest pain in the butt?
From a Qualcomm standpoint, but answering the question about what it takes to build all this technology.
Yes.
I think regulators across the board understood the importance of 5G. I have not met a regulator that said it's really important to be late on 5G. I don't think anybody wants to be late on 5G. And as a result, we've seen enormous amount of progress in getting spectrum allocated to 5G. I think the real issue is the time that it takes to build infrastructure. Investment in 5G infrastructure, especially millimeter wave, is like building roads and ports. It's critical infrastructure. And those things take time. Like, one of the number one obstacle you're going to hear from operators is site permit. Sometimes they have to negotiate municipality by municipality about permits to get new cell sites. But, the networks will be densified, and you're going to need all of that capacity for the promise of the fully immersive augmented reality that will replace phones and everything being connected 100% of the time.
This would not be a conversation with a CEO if I did not ask questions that make you nervous. Some people raise concerns about there not being enough studies about the effects of 5G on the human body. Is 5G safe?
Look, I have a very simple answer to this question. As we build new capabilities such as 5G, power is going down, especially when you think about reducing the number of base stations. The network's becoming more dense. So as you do that, the power becomes lower. If your
Power radiated from
the phone and from the tower. As you get closer to the tower, you don't need that much power to reach the tower. So as we move from 4G to 5G, I think we see a reduction in the amount of powers required to close the radio link. Now, also, you have a number of organizations. The FCC, for example, has rigorous programs, which they do a lot of tests uh, to validate, the safety of those devices. And I think we have has been a model for other countries to also to adopt the same things. Uh, Cellular's been around for a number of decades now. I think smartphone is our most beloved device today. And I would argue how it's difficult to answer those questions because but I'll argue that the data to date, have we seen in 3G and 4G, um, has shown that a lot of the initial concerns were not valid. We look at 5G, even though it's new, it's just less power. So we look at from a physics standpoint.
So from a physics, from a biology perspective, there's a lot of evidence, there's studies that show that it's not dangerous, that it is in fact safe. However, the concern that people have is when you scale technology exponentially, how will that change human civilization? I mean, that doesn't apply to 5G, that applies to every technology. You said smartphone is the most beloved device, but love sometimes hurts. So the
That's
impact on society, we don't know. And there's a little bit of fear. There's both excitement and fear.
It's a great topic of conversation, actually. So let me give you my perspective on this. And you started to see some things actually happening right now. So let me step back and let's talk about the fact that we are in a fully interconnected society. That when you look of the situation today, we talk about smartphones, largest development platform. So much now of our life, we are connected to the smartphone, and as a result, and we are all connected, and we're connected, and then we're building digital twins of everything, right? So when you look at that picture, of this connected society, you started to have the following thoughts, which I think are very healthy, which means in the same way that in the physical world, you're entitled to some rights, you have obligations, and there's a lot of things that protect your integrity. I think as a rule, we're going to see the society evolving, so those things extend to your digital being of people and things. And I think it's just natural. It's just natural. It's just a natural path. And you started to see things like that. For example, the Europeans has done a lot in this area. I'll say the Europeans probably ahead in the United States, thinking about privacy laws, digital privacy law. Most recent, the DMA, the Digital Markets Act, which I think is a great thing. I think we believe there's incredible thought into enable ability to regulate the digital market so that there's innovation and competition. So not a single company can control all the data and then decide, how things are going to be work on the digital realm. And even if we think about the potential of things like the metaverse as we're connecting physical and digital spaces. So I think it's a natural evolution. Of course, regulation and laws always follow technology. But the fact that we're moving to an interconnected society, there's no going back. We are a fully interconnected society. But there is opportunity to think about how the digital twin should people and governments should think about it so that we get the best of a technology without any downside.
Yeah, so when you say digital twin, that's one of the other things you're excited about, which is the metaverse, or basically building worlds in the digital space. And you have to start to think about all the basic human rights that transfer from our physical meat vehicles out to the digital copies of ourselves, representations of ourselves. It's really important to think about. The thing you mentioned about regulators that has been, this is me speaking, frustrating, is like you said, they follow technology. So sometimes they don't get the technology at all. So they're very clumsy in writing laws that censor that technology in interesting ways. They mean good, but they can do a lot of unintended damage. Now, both, it's a dance. It's a beautiful dance, but I just wish governments were better dance partners. I just see what they're kind of writing now about regulating social media and platforms like YouTube, and it's just really, really clumsy. They don't understand how machine learning works, how recommender systems work, and I just wish they kind of caught up a little more because it's really important to be great at regulation, but also it's important to let companies flourish and embrace this new wave of technology. That weird dance. I'm more and more learning, looking at public policy, how much positive government can do and how much clumsy negative it can do unintentionally, just out of sheer incompetence or lack of curiosity about tech. That's my rant about regulators.
I think it's a valid point. As I said before, I think the Europeans probably have a very good framework, but the way I'll think about it, we depend on have the ability to innovate. We depend on the free markets. We depend on the ability to create, technology that will be disruptive. But at the same time, I think the tech companies probably should spend time helping governments understand, helping understand
Yep.
ahead of time so that they can be better prepared.